everyone. Welcome to day 11 of our series. Today we will dive into logistic regression uh, and the Poisson regression modeling. Two specialized techniques for the modeling unique types of the data. First is logistic regression. It is ideal for the binary classifications tasks such as the predicting yes or no outcomes or true or false scenarios. And the next is the Poisson regression. In the Poisson regression used to model count data and such as the number of the events occurring in a fixed period of the space. In this session we will explain we will explore how these models works and their assumptions and the practical application in the fields like the healthcare, finance and the marketing. Let's get started. Logistic and the Poisson regression modeling using Python. This presentation delves into the powerful techniques of the logistic and the Poisson regression, crucial tools for analyzing and predicting outcomes in the diverse fields. We will explore their fundamentals, uh, implementations in the Python and practical applications by the end. You will be equipped to leverage these methods for the data driven insights and decision making. Introduction to regression analysis. First is predictive modeling. What is predictive modeling? Regression analysis is a statistical technique used to predict the relationship between a dependent variable and one or more independent variable, and it allows us to understand how changes in the independent variable affect all the dependent variable. Second is linear and non-linear relationships. Regression models can capture both linear and the non-linear relationship between variables. Linear regression assumes a straight line relationship, while non-linear regression uses more complex function to model the data. And third is the applications in the various fields. Regression analysis find wide application in the various fields, including finance, healthcare, marketing, and the social science. It helps to analyze the data, predict outcomes, and make informed decisions. Now, logistic regression fundamentals. First is predicting binary outcomes, second is sigmoid function, third is coefficient interpretation, and the fourth is application in classification. First is predicting binary outcomes. Logistic regression is a type of regression analysis specifically designed to predict the probability of a binary outcome, such as whether a customer will make a purchase or not. Second is sigmoid function. The core of the logistic regression is the sigmoid function because it transforms a linear equation into a probability between 0 and 1. These functions allow us to interpret the model's output as a probability of the outcome. Now the third is coefficient interpretation. The coefficients and the logistic regression model represent the impact of each independent variable on the log odds of the outcome. This provide insight into the factors that influence the probability of the predicted event. And the fourth is applications in the classifications. Now, implementing logistic regression in Python. How can we implement logistic regression in Python? There are total three types through which we can implement logistic regression. First is data preparation. Start by importing necessary libraries, and the second is model training. That is instantiate a logistic regression object from the scikit-learn library, train the model on the training data using the feed method. This process learns the relationship between features and the target variable. Third is a model evaluation. Evaluate the model's performance on the testing data using the matrices like the accuracy, precision, recall, and the F1 score. This gives you an idea of how well the model generalized to unseen the data. Now, how can we interpret a logistic regression in the results? Here it is like interpreting the result of a logistic regression model, examining the coefficient p values and the odd ratios. Coefficient indicates the effect of each independent variable on the log odds of the outcome. The p value determines the statistical significance of each coefficient, indicating whether the effect is truly present or just a random fluctuation. So the odds ratio quantify the changes in the odds of for the 1 unit increase in the independent variable, providing a practical interpretation of the model's finding. Now our next topic is, okay, just a second. Okay, fine. Poisson regression fundamental is our next topic which we are going to discuss. So first of all, you should count data analysis. Poisson regression is a statistical model which is used to basically count data which represent the number of times an event occurs within a specific period or the space. Now second is a Poisson distribution is a discrete probability distribution that describes the probability of a given number of events occurring in a fixed interval of time or this space, and it is a fundamental assumption underlying Poisson regression. And third is modeling rate of the of events. So Poisson regression models the relationship between the count variable and the independent variables, estimating the rate at which the event occurs. So this allows us to predict the expected count based on the value of the independent variable. And next is, how can we implement our Poisson regression in the Python? So as with logistic regression, start by importing the necessary libraries. So it's the first step. So first of all, you have to import all the necessary libraries, and after that instantiate a Poisson regression model from the states model library and feed the model to your data using the feed method. Now the model interpretation examine the model summary statistics, which includes p-values, confidence intervals, coefficients, and these values provide information about the significance and the direction of the effects of independent variables on the rate of the events. And fourth is predictions and analysis. So use the fitted model to make predictions on new data. So this allows you to estimate the expected count of events based on the values of the independent variable. Next is comparing logistic and the Poisson regression model. So logistic regression is used for the binary outcomes. On the other hand, Poisson regression analyzes the count data, which is the number of the events. Second is the logistic regression assumes a Bernoulli distribution for the outcome, while Poisson regression assumes a Poisson distribution for the count variable. And what are the applications of a logistic regression? That it is suitable for the classification task, whereas the Poisson regression is used for the count data analysis, such as predicting the number of customers visiting a store or the number of accidents on the highway.